Yes. apart from this part, if we want to do this thing, question, if you want to introduce a bigger amount of damping so that the peak becomes flatter, there are multiple different ways. Let me name acha তোমার প্রবলেম ছিল হচ্ছে মার্ক স্কিমের সেকেন্ড পয়েন্ট, রাইট?
থার্ড পয়েন্টটা
আচ্ছা, possible options একটা হচ্ছে we can introduce a flat piece of cardboard paper which has negligible mass compared to the block of the mass, which will increase the air resistance. এটা একটা পয়েন্ট হতে পারে। একটা হতে পারে we can place this entire setup into a oil or in a water, so that the medium itself is more dense, so it will introduce more damping force, so that you'll be losing the energy fast. That is also possible. So you are essentially changing the air into more dense, more viscous material. So that's another option. The third point could be something which we can look over here, which is question number 16. Increase the amount of damping without altering K or M. Some indirect references, etc. Sensible suggestion. Sensible suggestion মানে হচ্ছে, I mean, any logical way by which the damping can be increased. So there can be a lot of different possible options. The examination might have some example, but sensible suggestions can score mark, which examiners are allowed for this mark scheme to judge by their understanding of SHM and give marks for a lot of different possibilities. So this is not a specific mark scheme, but there can be a lot of different answers. So that's why the mark scheme did not specify any method. Nearly all candidates recognize the need for increase the amount of damping. Suggestions to increase damping were frequently feasible, although many failed to appreciate that the resonant frequency must not be changed. There were some who suggested the immersion in liquid, or changing the springs, or changing the mass.
Sir, মানে suggestion basically হচ্ছে immersion in liquid হতে পারে, right?
Immersion in liquid হতে পারে, or you can say that we can attach a small piece of cardboard around it, or you could also say that we can attach multiple feathers with very little amount of glue on its sides. Just increase the surface area somehow so that your damping mechanism that you're introducing has negligible mass compared to the system. That also works.
স্যার,
Yes.
কিন্তু আপনার যদি মোর ডেন্স মিডিয়াম আমি জিনিসটাকে প্লেস করি, তাহলে আমার টাইম পিরিয়ড চেঞ্জ হয়ে যাবে না? কারণ বেশি টাইম লাগবে না?
না, টাইম পিরিয়ড বেশি লাগবে না। তার কারণ হচ্ছে এই যে ইকুয়েশনটা ওই জন্য দেখালাম যে a equals to হচ্ছে -2k/m, where ওমেগা স্কয়ার equals to হচ্ছে 2k/m। তার মানে হচ্ছে ওমেগা স্কয়ার only k এবং m এই দুটো ফ্যাক্টরের উপর ডিপেন্ডেন্ট। Spring constant and the mass of the body. This omega is not dependent on the medium or the damping factors. That's why I brought this up. Yes, sir. Are you clear?
Yes, sir.
Moving on.
স্যার
Yes.
স্যার 15B এর মার্কিং পয়েন্টটা একটু বুঝতে পারছি না।
এটা
হ্যাঁ স্যার, আঁকতে পারছি, বাট মানে কোন পয়েন্টে মার্ক দিবে?
Straight line through the origin with negative gradient, endpoints of line correctly labeled. Endpoint of lines correctly labeled. আচ্ছা, এটা বি নাম্বার তো বুঝছো, মানে প্রথমটা তো বুঝছো।
হ্যাঁ, এন্ড পয়েন্টটা বুঝছি।
Endpoint of lines correctly labeled. আচ্ছা, এটা significance number প্রশ্ন দেখি। On the exercise figure 4.1, sketch a graph to show the variation of displacement x of the acceleration a of the force. What does that even mean? Endpoint of the graph, endpoints of line correctly labeled. If we go over here, most sketches showed a straight line through the origin with negative gradient. However, few added a quantitative aspect by labeling the endpoints of the line. Indeed, many were so poorly drawn that the line was unequal lengths in two quadrants. Acha, বুঝতে পারছি। We did calculate these parts over here, right? For example,
Yes, sir.
we did calculate that for an amplitude of 0.080 millimeter, we could have an acceleration of how much? What is the value of this?
ওটা 6200।
এত বেশি?
হ্যাঁ স্যার।
আচ্ছা, ঠিক আছে, হয়ে যাবে, ব্যাপার না। So what they are specifying, what they are demanding, that this graph should look like this. Let me help you see. You first of all draw, let me draw that with red, a straight line that should be nearly equal on both sides. So আর একটু ছোট করে রাখি যাতে করে আমি প্লটিংটা দেখাতে পারি। Okay, so এটা হচ্ছে তোমার লাইন আঁকছো, and then the additional labeling that you are expected to do, slash millimeter slash meter per second square ওকে এন্ড দেন এই বরাবর আসবে হচ্ছে পজিটিভ ভ্যালু, অ্যাক্সেলারেশন পজিটিভ ভ্যালু, এই বরাবর আসতে হবে হচ্ছে অ্যাক্সেলারেশন নেগেটিভ ভ্যালু। অ্যাক্সেলারেশন ভ্যালু ছিল কত? 6200।
Yes, sir.
তো 6200 মাইনাস 6200, এই বরাবর ম্যাক্সিমাম ডিসপ্লেসমেন্ট কত আসছিল অ্যাজ পার কোশ্চেন? 0.080, সো 0.080, এই বরাবর আসবে হচ্ছে মাইনাস 0.080। এই চারটা লেভেলিং
স্যার
করতে
স্যার মিটারে কনভার্ট করে নিলে সমস্যা হবে?
মিটার কমা করলে সমস্যা নাই, আমি মিলিমিটার লিখছি দেখে লিখছি। যদি এক্স মিটার লেখো তাহলে 8 into 10 মানে সামথিং লিখবা, এখানে মাইনাস 8 into 8 10 সামথিং লিখবা, ওয়ার্কস।
আচ্ছা, ঠিক
সামহাউ
আছে।
তোমার মানে মেইন পয়েন্টটা হচ্ছে সামহাউ তোমার এই দুইটা পয়েন্টের কোঅর্ডিনেট দেখাতে হবে। সো তুমি যদি এইভাবে এক্সিস লেভেল না করে মনে করো এই পয়েন্টটাতে একটা ডট দিলা, মনে করো এইটা একটা অপশন। আরেকটা অপশন হচ্ছে তুমি লাইনটা আঁকছো, ইউ হ্যাভ drawn the line, give a dot over here, write the two coordinates over here in the coordinate form, write the two coordinates over here in coordinate form, that also works.
বুঝছি স্যার, থ্যাংক ইউ।
বুঝে গেছে?
জি স্যার।
কি জন্য কি জি সুস্থি লাগে আমি খেয়াল করি নাই।
স্যার বুঝতে পারছি।
আচ্ছা ঠিক আছে, ওকে।
স্যার এই লাইনটা কি 6200 এর বিয়ন্ডে আর এক্সটেন্ড করবে?
না, এই কোশ্চেনের জন্য করবে না।
আচ্ছা।
স্ট্যান্ডার্ড কেসে করতে পারে, স্ট্যান্ডার্ড কেসে তো লাইনটা ইনফাইনাইটলি হতে পারে, মানে ইন এ স্ট্যান্ডার্ড কেস দ্য লঙ্গার your displacement or the bigger is your acceleration but in opposite direction. But for if you consider this graph exclusively for this math, then it would have that appropriate limit. No,
আচ্ছা স্যার।
not picking up calls in the class. Airplane mode, love it. Okay, moving on. এটা গেল 17. A spring is hung from a fixed point. A mass of 130 gram is hung from the free end of the spring. The mass is pulled downwards from its equilibrium position through a small distance d and is released. The mass undergoes simple harmonic motion. Figure 3.2 shows the variation with displacement x from the equilibrium position of the kinetic energy of the mass. So this is the shape. Use figure 3.2 to determine the distance d through which the mass was initially displaced initially. So which is supposed to be our amplitude. So amplitude হচ্ছে maximum displacement in one side. So what is this value? ভ্যালুটা কত হবে? এটা 0.5, এটা হচ্ছে ইচ ডিভিশন হচ্ছে, হ্যাঁ ইচ ডিভিশন হচ্ছে 0.05 না
0.8 I guess.
hold up. There are total 20 divisions to represent 0.5. So 20 divided by 0.5 করলে কত, 0.5 divided by 20 করলে এক ডিভিশন পাওয়া যাবে। 0.5 না divided by 20 gives you one division. Okay, that is 0.25. So that is 0. এখানে আছে হচ্ছে টোটাল 12 ডিভিশন into 12. হ্যাঁ 0.8 আসে, এক্স্যাক্টলি 0.8 আসে, সাবাস, গুড। সো 0.8 সেন্টিমিটার is your is the initial displacement. So that the frequency of oscillation of the mass is approximately 4 hertz. এটা দেখানোর সিস্টেম হচ্ছে এই যে এইটা দিয়ে এটা দিয়ে করতে হবে। আমাদের ম্যাক্সিমাম কাইনেটিক এনার্জি ফর্মুলা কি ছিল?
স্যার এইটা কত নম্বর কোশ্চেন ছিল জানি?
17.
স্যার 14C তে কি জানি একটা প্রবলেম ছিল স্যার।
14C প্রবলেম পরে বলো, কি
আচ্ছা।
পাপ পরে দেখাচ্ছে আবার, সমস্যা নাই, ডোন্ট ওয়ারি। So to calculate the maximum frequency frequency of the oscillation, we might as well use the maximum kinetic energy expression. The reason I'm taking this part, because in the question we don't have any available data to calculate the maximum. So to calculate the frequency of oscillation of 4 hertz, we don't have that data. So we might as well use this one, where the kinetic energy Ek can be given by, sorry, kinetic energy not total energy.
স্যার ডিসপ্লেসমেন্টটা কেমনে করছিলাম আমরা প্রথমে A1 এ যে বললো?
Initial displacement is the amplitude.
ও আচ্ছা আচ্ছা।
Okay, you guys know this expression, half m omega square square. So এখানে এটা আমাদের গ্রাফ থেকে বাইর হবে, half তো একটা নিউমেরিক্যাল কনস্ট্যান্ট, m দেওয়া আছে, a তুমি টাকে বের করছো। So from this equation you can calculate out omega. So omega is the unknown here, so এখানে কোশ্চেন মার্ক দিলাম। এরপর জাস্ট omega equals to 2 pi f, ওখান থেকে তুমি f টাকে সাবজেক্ট করলে তোমার f টা চলে আসবে। ঠিক আছে?
স্যার আমি
So
ফার্স্ট পার্টটা বুঝতেছি না।
this is the
মানে
equation for the total energy of the oscillation.
স্যার এইটা না, ওই যে A1 টা মানে পারি নাই, আমি বুঝতে পারছি না।
কোশ্চেনটা পড়ো, try to understand the meaning of the question. What does it say?
স্যার ই কে 0 হবে যেখানে, সেটা কি অ্যামপ্লিটিউড হবে?
Yes, technically yes, because that's the point where the object become momentarily at rest. So, or in other words, that's the location where the object moves maximum from the equilibrium position.
তার মানে স্যার গ্রাফটা যেখানে এক্স অ্যাক্সিস কে কাট করছে ওইটা লিখবো ডি।
Yes.
আচ্ছা স্যার, থ্যাংক ইউ।
No problem. Paper also B1 on figure 3.2, draw a line to represent the total energy of the oscillating mass. So you just draw a horizontal line through this point, which is simple. After many oscillations, the damping reduces the total energy of the mass to 1 millijoule. Now, important bit, 1 millijoule. This is the final value altogether. State the frequency using the graph, or otherwise state the amplitude. Frequency would remain the same. So এখানে just এই ভ্যালুটা কপি করে বসাবা। এখানে state the frequency এখানে approximately বলছিল না? If you write your given answer in 2SF, you can write 4.0 hertz. If you don't write your answer in 2SF, preferably write the calculated value that you have got over here.
স্যার কিন্তু এনার্জি তো লস হয়েছে, সো ফ্রিকোয়েন্সি কম হওয়া উচিত না?
এনার্জি লস হচ্ছে তো তোমার ড্যাম্পিং এর জন্য, বাট সিস্টেমের তো আমরা সিস্টেমের অসিলেটিং বডি বা হচ্ছে এগুলা কোনো কিছু চেঞ্জ করছি বলে তো আমাদেরকে বলা নাই। The question did not specify any option for changing the oscillating body's property. We can have continuous loss of energy by losing energy to the surrounding, under damping that is. Energy loss does not essentially require frequency to be changed.
এখানে আন্ডার ড্যাম্পিং হচ্ছে স্যার, এখানে আন্ডার ড্যাম্পিং হচ্ছে।
Yeah, that's usually the idea, because you say that after many oscillations, the damping reduces the total energy to something. So many oscillation means under damping.
স্যার ওয়েট, স্যার ওভার ড্যাম্পিং এ কি ফ্রিকোয়েন্সি চেঞ্জ হয় স্যার? হয় না তো?
Typically, if your damping system does not change the mass of your damping mechanism, there is no frequency change.
Yeah, সেটাই।
So now I was trying to clear Fardin's confusion. I think that worked out. Fardin, বুঝছো কি বলছি?
জি স্যার বুঝছি।
আচ্ছা ঠিক আছে, moving on. So we are trying to find out the damping reduces the total energy of the mass to 1 millijoule. So we might as well work with this one. So have a look. So আমি এখন যে কাজটা করব সেটা হচ্ছে তোমাদের বুঝায় করতেছি। কই গেল আমার এটা? So have a look. I need to zoom this out a little bit. Should I? আচ্ছা, ডিফিকাল্ট হয়ে গেল। আচ্ছা সমস্যা নাই, একটু থাকলেও হবে। দেখা যাচ্ছে না? হ্যাঁ দেখা যাচ্ছে, হ্যাঁ ওকে। Try to understand. Currently, we have some amount of energy over here. Can you get the maximum value of this one? Can you please tell me what is the value of this one? Here 20 division is 1 joule, so each division is 1/20. কত হয় এটা? Someone give me this number. Maximum energy কত ছিল? একটু ক্যালকুলেট করলাম, ক্যালকুলেটর কোথায় রাখলাম? আশ্চর্য। ও পাইছি। 1 divided by তোমরা কেউ আমার বলতে পারতেছো না ম্যাক্সিমাম এনার্জি কত আসছে?
স্যার 2.55 এর থেকে একটু বেশি হবে, একটু বেশি না।
Yes, sir.
স্যার 2.55 থেকে একটু বেশি স্যার।
আচ্ছা তাহলে 2.56
Yes.
কি
so let's say 2.56 millijoule. Okay, আচ্ছা এটা actually আমার গ্রাফটা I did not require this value for my graph, but I just wanted this number so that I could refer to this value for my discussion. Now the new kinetic energy new energy of the whole system is supposed to reduce to 1 joule, which means this peak should drop down to here. So what do I mean by this? I expect to have a curve that should look like this, and this curve should cut off my axis somewhere over here and here. That is what I want to find out. But I'm not going to do this whole thing because that is difficult to draw. So here is what I'm going to do. Have a count. How many divisions does 1 millijoule show you from the axis? How many divisions do you need for the 1 millijoule representation?
20.
Exactly 20.
20.
So if we draw a graph, so if we lift up our x-axis upwards so that the remaining number of divisions over here is also 20, we can pretty much get the exact shape. Let me explain what I mean. Let's say this small division is out of question, and here we have 1. So this is 6, 11, 16, 20, and slightly above, let's say over here. Let's say over here. So I'm going to try and draw a horizontal line over here. Let me draw that with green, with a bit thin line. So I can pretty much have this one considered to be my new curve. So this can be my new curve. Other than replacing the graph curve altogether, I'm bringing the horizontal axis up, and you will find out that crossings are happening at some point. What is this crossing point? What can be the coordinate of this point? Have a look.
0.4, 0.5.
This did not cut at 0.5. Slightly before
একটু কম, একটু কম।
একটু কম, because 0.5 হইতো আর এক ডিভিশন নিচে নামতে হইতো। এক ডিভিশন নিচে কিন্তু নামবে না, because this was not over here, this was over here. So you can say half a division less than 0.5. So plot this downwards. What do you get? Everyone, use your calculation skills and get me this number. What should be the coordinate of the x-axis over here? Give me this coordinate.
75. 0.475.
0.475 হতে পারে। I didn't hear the 0.4. So this was supposed
Sorry, sir, কেমনে ভ্যালুটা আনবো সেটা বুঝতেছি না তো।
এটা
Like, yeah, like কত ক্লোজ হবে, how would we know?
we don't. We are only looking at the graph and assuming that this is half division in front of 0.5. Just by eye
Yes, sir.
measurements.
Okay, sir.
Sir, it's more of
horizontal লাইনটা কিভাবে হলো?
875.
Vertical line কিভাবে হলো? আচ্ছা।
স্যার আমার ক্যালকুলেশন অনুযায়ী 0.4875 আছে।
875, sir.
0.4875
Yeah.
Yes, sir.
or আচ্ছা ঠিক আছে 0.4875 or 0.490 millimeter. Okay, acha. So this is the number that we are gonna work with. So let's have a look at the mark scheme. What number that is it that they are appreciating? This is number 17. 0.50 centimeter allow plus minus 0.03. So they actually went home. So 0.50 allow course, পুরোটাই allow করছে. So we are working with 0.487, or we could have written 0.489, which is very much within the range of plus minus 0.03. I would definitely go for this value because this is something that I'm comfortable with. I'm not comfortable with 0.5 because I can see it very well that if it was supposed to be 0.5, this peak should be one division below. This peak should be located here, but that is not. So I would definitely go ahead and write this number. So দেখো বুঝা গেছে কিনা everyone?
স্যার আরেকবার রিপিট করা যাবে? মানে হরাইজন্টাল লাইনটা বুঝি না যে ওইখানে যে হবে কেমনে বুঝলাম?
This entire curve needs to go down so that we can represent exactly 1 millijoule at its peak. So other than replacing the whole curve, bringing the whole curve down, we brought the x-axis up so that this much division is exactly equal to this many divisions. So now you can pretty much say, if this is your new x-axis, if this green line is your new x-axis, this much line can effectively represent 1.0 millijoule. 1.0 millijoule. So we counted how many divisions do we need to represent 1 millijoule and drew the horizontal line that many divisions below from the peak. বুঝা গেছে?
Yes, sir.
Beautiful. Anyone else? Any question?
স্যার গ্রাফটাকে যদি 1 মিলিজুলেই আঁকতাম তাহলে কি মার্ক দিত না?
এক্স্যাক্টলি এখানে যদি আঁকতা,
হ্যাঁ।
এখানে আঁকলে তোমাকে হুবহু এই কার্ভটাকে হুবহু এখানে রিপ্লেস করতে পারতে হতো।
ও আচ্ছা।
That wouldn't be a very easy job.
আচ্ছা স্যার।
So other than removing the curve down, I took the horizontal line up because that's easier for us to work with. That's the trick. But
হ্যাঁ স্যার বুঝতে পেরেছি।
এটা আপনি প্রথমে লেকচারের সময় একটা শর্টকাট দেখেছিলেন, ওটা কি এটা ছিল?
হ্যাঁ ওটাই এটা ছিল, এই কাজটাই করছিলাম। I did this exact thing.
So what you've done, sir, is it's the same as translating the curve down by 1.56 millimeters.
Yes.
Yes.
Shubhra, আমি তোমার প্রবলেম দেখতে পারবো না because I am not having my chat window open because I am drawing over here every once in a while. So please respond whenever we are at a problem that I am discussing that you have. And we're going to move forward. For all the previous problems, I can go backwards after I finish the one full run. So don't worry, I'll eventually solve your problem. So keep up. So that's enough for this number 17. I'll discuss number 18 in detail. Question number 18 is a interesting problem, but many of you might misunderstand this problem. And this one will give you some really good idea that why did we require that v equals to plus minus omega root over of a square minus x square. That expression was required. This will give you a good idea for that. Let's have a look. The question reads: the needle of a sewing machine is the needle of a sewing machine is made to oscillate vertically through a total distance of 22 millimeter as shown in figure 3.1. So this is the needle of the, this is the holder of the needle, and as you can see, this is the total amount of movement that this needle is going to work by. So one of the first thing that I need you to understand, other than going to the question, just try to think in your head, if this is the total amount of movement, this is supposed to be the highest position on the top, this is supposed to be the lowest position on the bottom. So wouldn't that essentially mean that somewhere halfway we should have equilibrium? Whenever an oscillating body moves up and down, if you have the highest and the lowest position labeled, the equilibrium is supposed to locate where?
At the midpoint.
At the midpoint. So appreciate that information first. So I'm going to take this up over here and do some pre-calculation, and then we're going to go move forward. So the first thing that I want you to appreciate is that for this oscillating body, I mean, this is the holder, this is the tip of the needle. So as the holder is going to move up and down, the tip of the needle is also going to move up and down in the same fashion, because this is one whole object. So if I draw over here, just for your understanding, the possible equilibrium position, let's say this is the equilibrium position, a horizontal line. So let's say this is my equilibrium level. So if this is my equilibrium level, how much is supposed to be your amplitude? এটু কত হবে? এই অ্যামপ্লিটিউড কত হবে?
11 millimeters.
অ্যামপ্লিটিউড এক্স্যাক্টলি 11 মিটার হবে। এটা কি সবাই অ্যাপ্রিশিয়েট করতে পারতেছো?
স্যার নিডলটা কিভাবে মুভ করছে ওটা ঠিক ভিজুয়ালাইজ করতে পারছি না, এটাই সমস্যা হয়েছিল কোশ্চেন করার সময়। মানে কোন পার্টটা মুভ করতেছে মানে কেমন জানি লাগছে।
এখন ভিজুয়ালাইজ করো। This is how the needle is going to move. It's gonna penetrate through the cloth up to this much depth and gonna rise up. The tip of the needle is 8 millimeter above the cloth level. So so for the needle tip, the equilibrium point would be 3 millimeter below the cloth. So this much gap should be how much? Think.
1 millimeter.
Not 1. Have a look. From the highest position all the way up to equilibrium, how much space do you have?
Oh, no, 10 millimeter.
No, not 10.
11
Not 11.
3 millimeters.
11 minus 8.
Yes.
11 minus 8.
millimeters.
3 millimeters.
This one should be 11 minus 8. Try to understand. এখানে এইটুকু হচ্ছে 11, এই যে এইটা তো ইকুইলিব্রিয়াম লেভেল না, তো তার মানে হচ্ছে কি এইটুকু হচ্ছে 11, as per the question এইটুকু হচ্ছে 8. Yes. So
And that is 3.
how much should be this gap? This is supposed to be 3 millimeter. ঠিক আছে? So this is the part that I need you to understand, that as this holder is going to move up and down with simple harmonic motion, the needle head or this pointy end, this is going to also move up and down in the same fashion. But the point that you have to understand, from the highest position, the equilibrium is located 11 millimeter below. So also for the needle head as well, the equilibrium position should be located 11 millimeter below, or that should be also 3 millimeter above the equilibrium position. Now, why is it important for you to understand this thing? Why am I badgering your brain for this part? Because we'll need this discussion a bit later. So, এই part টুকু মাথায় রাখো. I'm gonna go through the question and let's have a look. The oscillations are simple harmonic. The oscillations are simple harmonic with a frequency of 4.5 hertz. The cloth that is being seen is positioned 8 millimeter below the point of the needle when is maximum height. State what is meant by the simple harmonic motion. So you are going to put the definition over here. The displacement y of the point of the needle may be represented by the equation y equals to a cos omega t, suggests the position of the point of the needle at time t equals to 0. So you're going to place suggest the position of the point at time t. What should you write here? What could possibly be your answer for this one?
A.
8.
They didn't ask you any value for displacement or distance. They are asking you suggest a position. Writing A, does that fall? Does that give you an information about position? A
8
what?
millimeter. 8 millimeter.
So A meter is above the equilibrium in its maximum position.
You could have said 8 millimeter above the cloth, or you could have also said 14 millimeter below the cloth. Either of them could work. Think about it.
Sir, why 14?
Because of this position, which is the cloth. This much is 14 millimeter. 11 plus 3. So whenever we are working with cosine equation, it means that the starting position of the oscillating body was at one of the extreme positions. So it could be here, or it could be it could be here, as long as you're working with cosine equation. So it could be 8 millimeter above the cloth, or it could be 14 millimeter below the cloth. We're using the reference for cloth because the distance for the needle head is given with respect to the cloth position. So that's why we are using this part. So moving on. Determine the values of A, determine the value of omega. So এখান থেকে আমরা A বাই করতে পারবো. A এর value হচ্ছে 11 millimeter. You just write this over here, 11 millimeter. Omega would be given by 2 pi f. F is given, so you're going to calculate 2 pi f over here and you get that number. C number will say calculate for the point of the needle its maximum speed. Maximum speed is given by plus minus omega A. So you just write that equation over here. Since it's speed, so you don't have to give the plus minus. Simply write maximum speed equals to omega A. Because you're not working with velocity, you don't have to give plus minus. But if you are working with velocity, you should give plus minus, representing that this velocity applicable for both direction. But in this case, not required. So maximum speed equals to, or you can write V max equals to omega A, and then you just go ahead and calculate and write this value over here. Be careful to convert your units, because have a look. In the কারো চ্যানেল থেকে গানের সাউন্ড আসছে, মিউট করো নিজেকে। So over here, the amplitude is given in millimeter unit. Have a look. They didn't ask you to convert the amplitude in meter over here. So you could very easily give 11. But over here, they are expecting the speed in what unit? Meter per second. Which means whenever you're going to do V equals to omega A, that A has to be converted into meter. So be very careful about this kind of traps. Examiners tend to set them every once in a while. And then comes to question number 2, C2. This is the key part for which I went through the discussion. Have a look. Its speed as it moves downward through the cloth. Its speed as it moves downward through the cloth. We can solve this question in a very specific way. That specific way is, I'm gonna cut all of these. So we're going to try to solve this one. So to solve this equation, I'm going to try to draw this over here. The speed equation was given as the first differential of the displacement equation. That's possible. Or through effort, we had also developed this equation earlier as well, that V equals to plus minus omega root over of x square minus x square. Do you guys remember this equation? Anyone recall shape?
Yes, we do.
You should. Important part, যেটা স্টুডেন্টরা commonly mess up করে. What does this x mean? By definition, what was x?
Displacement
Displacement.
From
the equilibrium
position.
Equilibrium point.
From equilibrium.
From equilibrium, exactly. Very important. I love you all that you kids didn't mess it up. At least for those of you who actually did the response. This x means displacement from equilibrium. This x does not mean displacement from initial position. This x means displacement from equilibrium. Now have a look. When the needle head will penetrate through the cloth, this needle head is gonna come down by 8 millimeter from its original position. Makes sense? As it will enter into the cloth, how far away should this needle head be from its equilibrium? That should be 3 millimeter. Do I make sense? Let me zoom in on a bit more, just to give you a good idea. As the needle head comes in and hits the cloth, it has covered 8 millimeter distance downwards from the top downwards. So this position is how far away from the equilibrium level. So what is the value of x when this needle is painted into the cloth? That x equals to 3 millimeter. Do you appreciate this part?
Yes, sir.
That's the important bit. Student most commonly যে ভুলটা করে সেটা হচ্ছে they write this equation well, they are gonna go for the calculation. That's also very well, but in many cases they write over here x equals to 8 millimeter and they get the whole wrong answer because x
Sir,
does
can
not,
you explain the last part again?
which part?
Sir, যে equilibrium থেকে যে আপনি বললেন, like 8 millimeter কেন হবে না 3 millimeter কেন হবে?
এই স্টেটমেন্টটা বুঝো, read it through and try to take in your head, make sense out of it.
Basically, like clothটা penetrate করার পর like মানে ওই ইয়াটা চাইছে মানে ডিসপ্লেসমেন্টটা তাই না মানে স্পিডটা
ক্লোথটা পেইন্টেড করার ইনস্ট্যান্সে কত স্পিডে পেইন্টেড করতেছে সেই স্পিডটা চাইছে। ইয়েস।
ও আচ্ছা আচ্ছা, সো ইকুইলিব্রিয়াম থেকে কতটুকু উপরে ক্লথ, সো এটা 3 মিলিমিটার।
Yes. So that's the point that I was sure, no problem. That's the point that I was trying to get in your head, that x does not mean how much actual displacement has been made. X always means, for an oscillating body, x always means the displacement from equilibrium. Okay, that's why this x value is supposed to be 3, not 8. So এটা বসাবা, এ বসাবা, সবগুলো বসে ক্যালকুলেট করে দেখো v কত আসে। Help yourself and see if the answer matches. Do the calculation everyone on your own. Remember to convert the units accordingly. Don't mess up the units. Calculation করে দেখো এটা কত আসে। Give me some number.
স্যার, কোশ্চেনে নিডল এট ইটস ম্যাক্সিমাম হাইট বলতে কি বোঝাচ্ছে? ওটাই কি নিডলের
যে পজিশনে দেখানো আছে?
হ্যাঁ স্যার, ওটা ঠিক মানে কি? ওটা কি ইকুইলিব্রিয়াম নাকি ম্যাক্সিমাম অ্যামপ্লিটিউডে আছে নিডলের এন্ডটা?
You think about it. Other than I can tell you the answer, but I want you to think about this. The needle being
Acha,
its
sir.
maximum height, should that be equilibrium? Maximum height can be equilibrium.
Na.
There you go.
Sir, is the amplitude 11 millimeter?
Yes.
Sir, I got the speed as 0.299.
Ekjon bolo 0.299 meter per second.
Meter per second.
Okay, this is the answer from one of your classmates. Everyone, please have a look. Do you get similar numbers?
Yes sir, same আছে।
Answer match হয়েছে? Mark scheme এর
Yes,
সাথে? কত নাম্বার ছিল এটা? 18 0.30. Okay, yeah, work. Allow 1 SF. কেন? আল্লাহ জানে। আচ্ছা, এটা এক্সামিনেশন রিপোর্ট একটু দেখি আমরা। এক্সামিনেশন রিপোর্টে বলছে হচ্ছে although most answers did include the code for the correct expression of the calculation of the speed, there was much confusion as to what to substitute for the values of the amplitude and the displacement. Exactly what I told you. এবং এই কোশ্চেনটা তোমাদের স্কুলের পরীক্ষাতেও ফ্রিকোয়েন্টলি আসতে পারে। তোমাদের আমার এখানে যে ক্লাস নিব সেখানেও আসতে পারে, টপিক টেস্টেও আসতে পারে, মকেও আসতে পারে। এবং এতবার বলার পরও দেখা যাবে কিছু স্টুডেন্ট এখানে এই এক্স এর ভ্যালুটা অলমোস্ট কেউই ভুল করে না। এ ইজ অলমোস্ট অলওয়েজ কারেক্ট। বাট এতবার বলার পর দেখা যাবে যে কেউ না কেউ এই এক্স এর ভ্যালু ঠিকই 8 মিলিমিটার বসায় সুন্দর করে ম্যাথটা করে দিয়েছে। And scoring a -1 for this expression because the total mark was 3. So sorry, scoring a -2 for this expression because you'll still score the mark for the concept mark that you wrote the formula correct, and you are not gonna get the other 2 marks. বুঝা গেছে?
জি স্যার।
Yes, sir.
অর্ণব একটা কোশ্চেন করছে, অর্ণব সাহা, that is dy by dt equals to 0 করে c1 এর ম্যাক্সিমাম স্পিড বের করা যাবে না since expression of y is given. We actually can, but that is not the typical physics way that is taught in your syllabus. Mathematically we can. This is absolutely correct. What the process that you mentioned is going to work, but that is not taught in your 970 syllabus. So we prefer not to stick to that. That is also why we actually went for this expression that plus minus omega a was taught to us. So
স্যার এটা নিয়েই লিখছিল এক্সামিনার্স রিপোর্টে, আমি কালকে যে ম্যাথসটার কথা বলেছিলাম।
এখানে
হ্যাঁ স্যার।
কই কত নাম্বার? C1 এ the calculation was completely successful by most candidates using the candidates values for the amplitude as stated in B2. কই কিছু তো বলে নাই। V equals to
সেটাতে
omega a.
বলেনি। ও আচ্ছা, মানে এরকম একটা তো বলছিল।
ঠিক আছে আমি পাবো, সমস্যা
আমি
নেই,
পাইলে দেখাবো।
নো প্রবলেম, সামনে পড়বে। So moving on from this question, 19 এ কারো প্রবলেম? সুব্রজ্যোতি 19 এর BC তে প্রবলেম দিছো, so you might as well look at this one. Okay, have a look. The variation time t for the distribution x of the cone of the loudspeaker is shown in figure 4.1. So this is the distribution time graph having starting from 0 position. So this is a sine curve. Use figure 4.1 to determine for this oscillation the amplitude, the frequency. এগুলা কষ্ট করে বাই করবা, এগুলো বাই করতে পারো। State 2 times at which the speed of the cone is maximum. Speed of the cone is, this is a DT graph. DT গ্রাফের gradient যেখানে highest হবে সেখানে হবে তোমার speed maximum হবে। And DT graph, we know from the property of simple harmonic motion that maximum speed happens when the particle or object passes through the equilibrium position. So maximum speed can happen at 0 time, at 0.6 or at 1.2. So you can write any of those 2 times at over here. The acceleration of the cone is maximum when the object is any of the peak positions. So for the displacement, state 2 times, state 2 times where the acceleration of the cone is maximum. For those positions, you have to choose either this time frame or this time frame or this time frame. So get this time frame, for example, this can be 0.3 millisecond, or this could be 0.9 millisecond, or this could be 1.3 millisecond. Any of those 2 values you can mention over here and get full marks out of it. Basic idea.
Sir,
number হ্যাঁ বলো।
0.9 এ তো মিনিমাম না কার্ভ?
0.9 এ তোমার amplitude maximum in opposite direction. We don't say that to be minimum. Minimum is referred to as 0. 0.9 amplitude maximum in opposite direction. That's the expression that we use. বুঝছো কি? আচ্ছা, so এরপর সি দেখি question number C. The effective mass of the cone is 2.5 gram. Use your answers in A to determine the maximum kinetic energy of the cone. Maximum kinetic energy half m omega square a square. তুমি A জানো, omega জানো, omega জানো না, F জানো, F থেকে omega বের করবা. You place those equations over here, you get the number. শুভ্র বুঝছো?
স্যার আরেকবার রিপিট করেন তো।
half m omega square a square.
হ্যাঁ স্যার এইটা ইউজ করছিলাম।
হ্যাঁ
হ্যাঁ এটাই ইউজ করছিলাম।
মিলে নাই, মিলার তো কথা।
আচ্ছা স্যার এখানে কি বলছিল ম্যাক্সিমাম এনার্জি, রাইট?
Yes.
স্যার পটেনশিয়াল এনার্জি যদি বলতো তাহলে কি ইউজ করতাম?
Maximum energy, maximum potential energy and maximum kinetic energy value same. Maximum means for a specific time instance, not over the entire motion. Maximum does not exist for the whole motion. But the value is same as long as we don't consider damping.
ওকে
স্যার এটা কেমনে ক্যালকুলেট করব, এই যে হাফ এম এ স্কয়ার ওমেগা স্কয়ার?
Oh, A is the amplitude. You have a look over here. The amplitude is 0.2 millimeter. The maximum distance in one side.
স্যার কিন্তু আপনি তো বলেছেন যে 0.9 মিলিমিটার মানে অ্যামপ্লিটিউড ম্যাক্সিমাম।
0.9 millisecond was the time instances where the maximum amplitude was achieved. 0.3 millisecond or 0.9 millisecond or 1.3 millisecond. These are the times where it was achieving maximum distance. I quoted x-axis values, not y-axis values. বুঝছো?
ইয়েস স্যার বুঝছি, থ্যাংক ইউ।
Sure, no problem.
স্যার
Yes.
19C এর স্যার কিভাবে মানে বুঝাই লিখবো কিভাবে?
This one.
19C স্যার। হ্যাঁ
কিছু বুঝাই লিখবা না, তুমি যে ইকুয়েশন লিখবা।
ওইটা না, সি এর সরি স্যার D2।
দিতে যাই না
19
এখন,
এর
দিতে
D2।
দেখতেছি।
আচ্ছা স্যার।
The loudspeaker may be designed so that resonance is of the cone is avoided. State what is meant by resonance. Definition লিখবা। Truth about stated briefly explain one other situation in which resonance should be avoided. It could be any of the cases, the most common cases that you have come across through the discussion, that resonance should be avoided for tall buildings and long bridges, so that the vibrational energy through wind from wind is not added up or is not accumulated over time, and it starts to oscillate at a very large amplitude, or resonance happens, and so because that might lead to some structural damage, or the stress would be too much on the structure. অনেক কিছু লেখা যায়, আমরা মার্কসিম দেখি, মার্কসিমটা বুঝাই দিই। So they have used example, and they have also mentioned any feasible example, so which means these are not limited to the answer. There can be other logical answers as well. Let's have a look at this expression. Metal planes on machinery vibrate or oscillate. Motor in machines impresses frequency on panel, or car suspension system vibrates and oscillates. Going over bumps would give a large amplitude of vibrations. Acha, so they have given these two expressions, but I would essentially go for the idea for the buildings, because that comes to my head primarily for the hazard cases of resonance. One household example to avoid resonance is actually washing machines. Do you know washing machines? The way washing machines work is that whenever you start the washing machine, they start to rotate slowly, because initially they are trying to mix up the detergent with the water and the cloth. But eventually, when they are done washing your cloth, they are trying to rinse your cloth. They start to rotate the disc or the bucket at a pretty high speed. So they slowly speed up from a low speed to a high speed. in many cases, somewhere within this frequency, angular frequency, it matches the natural frequency of the entire washing machine. If you don't have appropriate damping mechanisms, your washing machine is gonna start walking in your room, which I can show you through some video just to give you this idea.
স্যার মেটাল প্যানেলস এর কথাটা বুঝলাম না, মানে ইজ ইট মানে যে কোনো মেটাল প্যানেল বলতে তো আমরা বুঝি আচ্ছা এনি ফ্ল্যাট শেপ অফ মেটাল, রাইট?
Yes. The heading itself says. So what they did, they removed all the bases. Do you see that the base is entirely bare? The metals, you can see the metal. Do you see the metal? So all the damping mechanism that this washing machine was built up with, they were removed entirely. And now they are gonna start this washing machine. So have a look what is happening. Oh, just for the sake of interesting, they have put some metal stuff inside as well. Give me up, give me up. One point you see it starts to actually move. It still haven't reached its natural frequency, but it is going there. There comes the frequency. What happened? Oh, the amount of mass inside was less, so they required more mass. I might as well stop. I robbed you of the interest rate. Second start. This is what happens when you don't have damping. Now imagine the same thing happens with the
Depending on breed, and they had a very high the soldiers were passing, so there was a resonant frequency somehow. The whole breed collapsed, something like that.
all that they did is that they use the damping mechanism that is the effect. The reason they added that additional mass inside the rotor is that an eccentric mass which is most likely for some electrodes when it is introduced in your drum. But the electrodes are supposed to be at uniformly distributed around the circumference of your drum. They are likely to be located at one point. So those masses that they have introduced, they are also locked up in a certain location in the and you are having this. So it is quite sound বেশি আসতেছে?
Is it just me or is it crazy?
So I think I made my point. It's not take a while.
This is strangely satisfying.
I know, right? It has got rid of all these numbers and now they are showing let's move on. So you could mention any of these logical cases for washing machine, for bridges, and something like that. Also, this question was answered in terms of examples, so you could write any of the other person. Have a look at the examiner's report, what it says. Most candidates could quote an example. However, many fail to state what could cause the vibrations and that it is vibration which causes the problem. In answers such as soldiers must break step when they cross a bridge to avoid it collapsing does not explain the effect of resonance. Yeah, this is also another way that soldiers usually move from one place to another place marching, but whenever they pass over a bridge, they are always instructed in their training that they shouldn't all step on the bridge at the same time, because if it's somehow that their stepping frequency matches the natural frequency of the bridge is meant to collapse. So they are asked to walk randomly or like regular people whenever they're passing over a bridge.
মানে স্যার মার্চিংটা একটা ফ্রিকোয়েন্সি হিসেবে কাজ করে।
Yes, I mean you are stepping, all the people are stepping on the bridge at the same time, so you are adding energy all on the bridge at the same location, same instance. That can give you short impulsive forces, might lead up to resonance if those frequencies match with the natural frequency, which is possible. Make sense?
Yes, sir.
Yep. So you could write any of the logical questions, logical examples. 20 তে কোনো problem?
হ্যাঁ স্যার 20C।
আচ্ছা দেখবো।
Yes, sir. 20C.
The variation with distance x of acceleration a of the center of a cone of a large sphere is shown in figure 3.1. So yes, we have the graph acceleration versus displacement. Beautiful. State two features of this. আচ্ছা, এটা হচ্ছে a equals to minus omega square x, দুটা ভ্যালু বসাবা, গ্রাফ থেকে দুটা ভ্যালু বসায় ওমেগা ভ্যালু ক্যালকুলেট করলে হবে। C তে বলছে, have a look at C. The frequency of vibration of the cone is now reduced to 1/2. 1/2 means half. It doesn't mean 1.5. It means 1/2. The frequency of vibration of the cone is now reduced to 1/2 of that calculated in B. The amplitude of the vibration remains unchanged. On the axis of figure 3.1, draw a line to represent the variation with displacement x of the acceleration a of the center of the loudspeaker cone. Okay, that's pretty simple. We can copy this up. So what was our original so if I go ahead, try to understand that we are trying to calculate the new frequency for our new new amplitude. Sorry, we have reduced the omega half, right? So one of the ways that we can do this is that a equals to minus omega square x. We all agree that, right? Now here the omega was reduced to half. So you can find out the new omega. What should be the new omega for this system? Our initial omega was how much? Initially আমাদের এই ফ্রিকোয়েন্সিটা কত আসছিল?
250
exactly 250 আসছিল
না 251.6
আচ্ছা 251.6 so আগের so let's say I'm going to write that frequency old was 251.6 hertz, so frequency new should be half of that. If you wonder why, because I know from the equation omega goes to 2 pi f, so if omega is supposed to become half, f is also supposed to become half, so new frequency should be half of that. Whatever that is, so you calculate that part. So I can write over here a equals to minus 2 pi 251.6 divided by 2 squared into x. So you have this expression. Now this equation does not essentially help you much because you don't get a coordinate. What would be smart for you is that replace any of the values of a or x in your equation from the graph. So let's say I'm going to replace the one value of x to get one value of a. Now why am I going to replace one value? I'm going to explain in just a bit. Just give me a value that give me one value for x. Let's say the x value is 0.3. I'm going to use the terminal value. If I place x equal to 0.3 over here, I'm going to get some number for acceleration. Give me this number. A equals to minus this whole thing squared into 0. Acceleration ki meter per second square dawa? Meter per second square dawa, sure, why not? So this should be what? 0.
acceleration তো minus 750 হবে
0.003 হবে। দাঁড়াও আমি বলতেছি, give me this number, I'll quench all of your questions just in a bit. 0.003 এটা হচ্ছে তোমার x এর ভ্যালু in terms of meter। এই নাম্বারটা কত হয় আমাকে বলো, give me this value।
minus 42.9.
42.9 meter per second square. So if you wonder এটা কেন করলাম, what I'm trying to get is that for a known value of x, I tried and calculated the unknown value a. How does this help me? You see, one thing that I know for a fact from the property of SHM, and that is oops I need more space. Okay, one thing that we know from the idea of simple harmonic motion is that this graph of a versus acceleration versus displacement will always be a negative gradient straight line that will definitely pass to the origin. So one point of any of those graphs for any system, what that is, as long as you are working with simple harmonic motion, you know for a fact that this will go through the origin. So 0, 0 is a known point. What I simply did by replacing this, that I found out one more point. So for the new system where the omega was reduced to half, I can very well see that one of the new point, let me draw that with red, for 0.03, you're gonna get at minus 42.9. So let's say minus 43. Can we label minus 43 here? Huh?
Sir,
That's 190.
এটা ভুল হইছে?
minus 187, sir.
আচ্ছা এটা কত হবে?
Minus 187.43.
Minus 187.4. 8. 3. আচ্ছা সমস্যা নাই, ভুল হতে পারে। অর্ণব দেখো তোমার ক্যালকুলেশন কত ভুল হতে পারে বাবা, এটা একটু চেক করে দেখো। So this is the new accelerations that we are supposed to have for amplitude for our displacement of 0.03. Now if you wonder, 0.03 কেন নিলেন? I could have chosen any value, doesn't matter. I have chosen 0.03 because I wanted to. So have a look, 0.03 এর জন্য আমাদের নতুন acceleration হবে হচ্ছে minus, let's say minus 190, which should make it easier for me to draw. This is 0, this is minus 250. So each small division over here gives you how much? 25. ঠিক কি না? বলো মান, respond. Each vertical division gives you how much acceleration? আর কথা বলা
25 no?
হ্যাঁ 25 হওয়ার কথা, আমি বললাম 25 হবে কিনা, বুঝতেছো কিনা?
হ্যাঁ স্যার
10 division is representing 250, so each vertical division gives you 25. তার মানে হচ্ছে we want to find out how many 190. So 190 divided by 25 করে দেখো, 190 divided by 25 করে দেখো কত ডিভিশন আসে। 190 divided by 25, 7.6 ডিভিশন।
7.6 হয়েছে।
তার মানে হচ্ছে এখান থেকে 1, আচ্ছা আমি তো উপরের দিকে যাব কারণ পজিটিভ আসছে, সো এদিকে হচ্ছে 5 7 7.6 হচ্ছে ধরো অ্যাবাউট এই জায়গায়, ঠিক আছে? সো আমি এখানে এখানে লেভেল করা, আচ্ছা ভুল লেভেল করছি অ্যাকচুয়ালি, এখানে না, এখানে লেভেল করা দরকার ছিল। 7.6 হচ্ছে এই জায়গায়, তার মানে হচ্ছে this should be my new point here, this red thing. I might as well give a bit of a blobs are not appreciated, but I'm just showing blobs to make sense with you. So মনে করো এটা হচ্ছে আমার নতুন একটা পয়েন্টের কোঅর্ডিনেট হবে for the new system. এটা আমি বাই করছি। So and by property of SHM, I know that the line should also go through the origin, and I can now very easily complete my line. See what I mean? That's it. And question করো। Ask me questions.
স্যার
Yes.
স্যার আপনার এখানে 0.03 নিয়েছেন কেন? এখানে 0.3 হওয়ার কথা না?
Nah, this was in millimeter, but this was in meter per second square. That's why I wrote 0.003. I converted millimeter into meter because I wanted the acceleration calculated in meter per second square.
Oh, acha, বুঝছি।
Anyone
Sir,
else?
0.003. If you divide 0.3 divide by 1,000, and then
জি
would it
স্যার,
be
ওটাও তো
0.003 or 0.0003?
এখানে জিরো একটা বেশি হওয়ার কথা।
জানি স্যার, একটু confused.
হ্যাঁ স্যার।
0.3 divided by 1000 গুলো কত হয়? হ্যাঁ রে।
হ্যাঁ স্যার, আরেকটা হবে প্রবাবলি।
শিট। তাহলে তো পুরো ম্যাথই ভুল হইছে। তাহলে তো মানে অনবরটা ঠিক ছিল।
আমি 0.3 ডিভাইড বাই 1000 করেছিলাম স্যার।
আচ্ছা, সো আমি এখানে একটা জিরো দিলে আমার অঙ্ক হয়ে যাবে। Now I'm covered.
Yes.
Okay, beautiful. I love you. So yeah, so that works. So did you understand the methodology for this? I mean, why did I go for this one? If you kids wonder, could I use 0.2? Yes, you could use 0.2. If you use 0.2, you could have calculated this number. But then again, your line should not be extended from 0.2 to minus 0.2 because the question doesn't say anything about reducing the amplitude. So your line must as well be from the very right of the graph all the way to the very left of the graph. Only you're going to have a changed gradient. All that you're trying to calculate out is the different gradient, and you're pretty much covered. If you don't want to use the very simple idea which is freely available to you about the 0 point, if you don't want to use this idea, I don't know why you shouldn't, but let's say if you don't, then you can also use one more idea, is that you can see that this line is symmetric on both sides. So if you have a point over here, logic tells us an identical point should be available over here as well. So you find those 2 points, join them through, well, essentially this line will pass through the origin as well. So there are multiple different ways to do this math. Now I showed you this part. Any further question, or we'll move on?
Move on, sir.
Move on. Okay. So number 21. A student sets up the apparatus illustrated in figure 3.1. 21 problem is not there.
No sir.
21
No,
mark corner. Okay, 21 seems to be simple. Love you kids.
Sir, 22 বিটের প্রবলেম আছে।
দেখতেছি।
Yes sir.
আচ্ছা 22 এর মার্ক স্কিমে ভুল আছে। I think 22 এর মার্ক স্কিমে কোন একটা পয়েন্টে position of the cylinder ভুল লেবেল করে দেওয়া আছে. I have been trying to solve this problem for years. I couldn't come to a logical solution. But I'll also struggle with you kids to introduce the problem to you. 20 number question খেয়াল করো, আমি দেখতেছি। A cylinder and piston used in a car engine are illustrated in figure 3.1. The vertical motion of the piston and the cylinder are assumed to be simple harmonic. Which means you consider it to be simple harmonic. The top surface of the piston is at AB when it is at the lowest position. So this is the lowest position of the SHM. It is at CD when it is at the highest position, as marked in figure 3.1. So these are the two extreme positions. So somewhere halfway we should have equilibrium, which is not labeled in the figure, but you should know this from your idea. The decision D of the piston may be represented by the equation D equals to minus 4.0 cos 220t. So minus 4.0 এখানে কিন্তু ইউনিট দেয় নাই, দিছে? এখানে কিন্তু ইউনিট দেয় নাই, দেখো প্রমাণ
না স্যার।
বাট পরের লাইনে লিখে দিছে, কি লিখে দিছে?
Centimeters.
Where D is measured in centimeters. তার মানে হচ্ছে this is supposed to be amplitude. So you do understand that how so the amplitude of the motion is supposed to be 4 centimeter. So if I have a halfway, if I imagine a halfway mark over here, which is supposed to be my equilibrium, on one direction this is supposed to be 4 centimeters. So the entire length should be how much?
8 centimeter.
8 centimeter. Beautiful. Remember this information, পরে কাজে লাগবে. So এখানে বলছে determine the state the distance between the lowest position of AB and the highest position CD of the top surface of the suspension. একটু আগে বললাম 8 centimeter. So you can write 8.0. Don't write only 8 because this is written as 4.0. You might as well maintain the same SF. Write 8.0 centimeter. Two-তে বলছে determine the number of oscillations made per second by the piston. So number of oscillation বের করার জন্য we need to compare this equation with our standard equation A cos omega t. So here 220 represents omega. 220 represents omega. So omega equals to হচ্ছে 2 pi by capital 2 pi f না? Number of oscillations per second necessarily means what? Frequency na?
Yes, sir.
Think in your head. Number of oscillations per second. Does it mean
Sir.
frequency?
1/t.
Yes, sir, it does.
So omega equals to 2 pi f বসাবা ওখান থেকে f টা ক্যালকুলেট করে বের করলা আচ্ছা a2 হইলো থ্রিতে বলছে বলো
2 pi f মানে 2 pi by t মানে হচ্ছে তো পিরিয়ড একটা ইয়ার এই কারণে
না 2 pi by t মানে পিরিয়ড না 2 pi by t এর t টা হচ্ছে পিরিয়ড 2 pi by t টা হচ্ছে অ্যাঙ্গুলার ফ্রিকোয়েন্সি ওমেগা
হ্যাঁ পিরিয়ড আর অ্যাঙ্গুলার ফ্রিকোয়েন্সি তো সেমই হচ্ছে তাহলে আর
কোনটা
না আমি উল্টা বলতেছি
হ্যাঁ তুমি উল্টা বলতেছো এক্স্যাক্টলি
স্যার হ্যাঁ আমি উল্টা
বুঝছো
বলতেছি হ্যাঁ ঠিক আছে
আচ্ছা হ্যাঁ বলো someone said স্যার আচ্ছা no never mind থ্রিতে বলছে on figure 3.1 draw a line to represent the top surface of the piston in the position where the speed of the piston is maximum speed of the piston is supposed to be maximum exactly at the halfway point so you just measure this up with your ruler and draw a dotted line over here exactly at the halfway point did they ask us to do some labeling they didn't ask us to do any labeling so you just draw a simple line over here horizontal line and you're good to go get score this 1 mark calculate the maximum speed of this piston maximum speed formula key
Omega
maximum
A.
speed
Sir, omega A.
omega A
Minus
you
omega.
place that over here omega এখানে দেওয়া আছে 220 a তোমরা একটু আগে বের করছো এটা but important আচ্ছা এখানে unit the unit over here is also centimeter per second so since the unit is already centimeter per second don't bother converting this so every single time you have to be careful about the unit that they are asking they are looking for the answer in I mean unit mismatching can be one of your biggest scare in all of your paper 4 worksheet so get used to this you shouldn't think this as a continuous problem this is just a what can I say occupational hazard for paper 4 if I may put it that way
স্যার কিসের কথা বলছেন
the unit matchup you have to look what is the unit that they're asking the answer in and you do your math according to that if you don't consider the unit thing you can in many cases let's say in 80 to 90% of the cases you're going to be in trouble have a look at the unit first then go for the math পড়ান বুঝছো কি বলতেছে
Yes, sir.
Yes.
আচ্ছা have a go for B number the engine in the car has several cylinders each of these are the three of these cylinders are shown in figure 3.2 so we have 3 cylinders over here A B C D and blah 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 X is the same cylinder and piston as in figure 3.1 okay Y and Z are two further cylinders with the lowest and the highest positions at the top surface of each position indicated okay they have given us the reference values I might as well take this picture out because I hope this picture comes as a single piece. I hope. No, it doesn't come out as a single piece. Problem. Okay.
So just use the snip tool.
I will, but there is another way that I can work. Is there a way that I can work? I can use the snip tool for the entire page, but
স্যার পিআরটি স্ক্রিন করে পরে পেইন্টের মধ্যে ক্রপ করে দিতে পারেন
কপি পেস্ট করেন
কবে করব okay I have 3 parts right আচ্ছা সমস্যা 3 parts হলে কবে paste করা যায় I was wondering that if I had too many pieces I don't which is a good thing okay so that's one and then that's two good I'm awesome okay so let's have a look we are over here I have zoomed out a little bit because Microsoft Paint cannot be zoomed dynamically so that's a problem and I'm not good with Paint 3D so I'll be using this one but bear with me can you read is it legible
Yes,
জি
sir.
স্যার
so the pistons and cylinders each have the same frequency of oscillation but they are not in phase so we have 3 pistons they are not in phase at a particular instant in time the piston of the top of the piston in cylinder X is as shown in cylinder Y the oscillations of the pistons lead those of the piston in cylinder X by a phase angle of 120 degree এই যে leading and lagging এর কনসেপ্ট চলে আসছে complete the হ্যাঁ যারা করতেছো hold your horses complete the diagram of cylinder Y for this instant by drawing a line to show the top surface of the piston, and arrow to show the direction of the movement of the piston. Okay. Just to make sure that this is the figure that we're going to work with, I might as well bring some sine curve, or minus cos curve. What kind of curve do you need? What kind of curve do you need to start with for the cylinder X?
Minus cos.
Minus cos curve.
Cos curve.
স্যার আমার মাথায় ক্লিক করে নাই মাইনাস কস কাপ কেন হবে
-4 cos 24
ওই দেখো।
20t.
ও আচ্ছা আচ্ছা বুঝছি বুঝছি
মাইনাস কস কার্ভ এগুলো কি দেখা যাচ্ছে?
আপনি ডেসমোসে যান
স্যার এগুলো তো করোনা ভাইরাস স্যার।
স্ট্যাটিস্টিক্যাল গ্রাফ দেখলে এখন করোনা ভাইরাস মনে হয় না? কি মজা।
স্যার আপনি ডেসমোসে যান
I'm awesome, so I'm not gonna go through any of the trouble. I'm gonna go copy a sine curve, basic sine curve, and convert that into minus cos as per my requirement. Don't worry. I hope I know my shit. We need a bit high definition, so settings, tools, size, large. Voila. This one seems good. This one seems very good. And it paste করলে এটা কুচকুচে কালো হয়ে যাবে. Exactly as I had expected. So I might as well white this. And what kind of what was I trying to get?
Minus cos.
মাইনাস কস
Minus cos. Okay. Wait. Don't despair. Oops. So for minus cos curve, I would require this thing to be copied from here to there and have it flipped vertically.
স্যার
And place it up over here. Bala.
স্যার অর্ণবকে ঢুকতে দেন
ওয়েটিং লিস্টে কেউ নাই তো?
জানি না স্যার ও বললো যে ও এখনো ঢুকতে পারে নাই
আচ্ছা তাহলে এটা একটু আগে হইতে পারে। ওকে ঢুকাই ফেলছি একটু আগে কিছুক্ষণ আগে একবার। ও আমি বুঝতেছো কি করতেছি?
Yes sir.
ও নো। আচ্ছা এইটুকু হইলে আমার মনে হয় কাজ হয়ে যাবে। আচ্ছা just for the sake let me just elaborate this graph a little bit more because I can, why not? I might be wrong in my declaration of saying that this mark scheme is wrong altogether. I might not have solved this problem the correct way in any of my earlier years. That's also very much possible. I just told you what I have come across, but I'm still gonna try to solve this problem for all of you so that we can get an idea. Now, if you wonder, sir, you are drawing all of these graphs. Should we do all of these graphs? The answer is yes and no. Depends on how well can you visualize graphs in your head. I mean, if you have a Desmos graph calculator within your head, be my guest. Don't draw the graphs. If you don't, you should. You definitely should. So let's say this blue graph is our X. So label this as X. The next one, Y is leading by 120 degree key compared to X. Leading graphs would always have their crests behind. Remember?
Closer to the
On the left.
y-axis.
Yeah, on the left. And lagging graphs are supposed to have them in the front. So which means I need to now replace this entire graph, and I'm definitely going to draw that in a different color. So
Sir, how would
yes.
we know like 120 degree আমি কেমনে left মানে like how would we know 120 degree left
Yeah, that's exactly that's exactly what I'm trying to talk about. Hold your horses. I'll help you for that. Have a look. আমি এই পিকটাকে এদিকে সরাবো। আচ্ছা, তার আগে আমি এই গ্রাফের কালারটাকে চেঞ্জ করে দিই। Let me make this into, let's say, green. That worked very nice. Beauty of PNG images. So একটা জিনিস ভালো করে খেয়াল করো। I did not label the horizontal axis over here, but I need you to tell me how much is the angle from here to here? How much is the angle over here? এইটুকে angle কত?
90.
90
45
45 কেন হয়?
No, 90.
মাইনাস 1 থেকে কমে 0 হইতেছে। এটুকু হচ্ছে 90। বুঝো?
90 স্যার।
এটুকু হচ্ছে 8টা 90, এটুকু হচ্ছে 8টা 90, এটুকু হচ্ছে 8টা 90। সো এটুকু হচ্ছে একটা সাইকেল, ঠিক আছে? আচ্ছা। সো বুঝার সুবিধার জন্য মনে করো আমি এখানে এই জিনিসটা আঁকি। বাট এটা একটু পরে ঢাকা পড়ে যাবে। ঢাকা কেন পড়ে যাবে সেটাও একটু পরে বলতেছি। মনে করো এখানে কিছু রেফারেন্স লাইন দিলাম। সো লেটস সে দিস ইজ আওয়ার 0, এখানে হচ্ছে 90, bad poor choice of color, 90, 180, 270, 360 goes on like that, ঠিক আছে? So you need to shift this peak by 120 degree on the left. So এদিকে আছে 90 ডিগ্রি, এটাকে এখন তুমি তিন ভাগ করো, চোখের আন্দাজে তিন ভাগ করো। লেটস সে একটা হচ্ছে এখানে, একটা হচ্ছে এখানে। So you need to bring the peak over here. See if you can agree with me. To draw a leading graph of 120 degree, you need to shift each of these crests or these troughs by 120 degree to the left. So I approximately roughly position the 120 degree left position. Do you agree on this position in the first place? Everyone?
Yes sir.
Yes sir.
Yes sir.
So I'm going to copy these up. এই যে এখান থেকে এটুক 90 আর এটুক হচ্ছে 90 ডিগ্রি 1/3। এই যে I divided the 90 this 90 degree into 3 pieces.
আচ্ছা বুঝছি
90 plus 30 gives you 120.
ইচ্ছাচ্ছেন স্যার আপনি?
হ্যাঁ, because this one says that it is leading that one.
Okay.
So let me just cut off from this point because I don't want to have the problem of all of those parts, and I'm going to select transparent selection, and let's try to do that. Bam. So this green one is supposed to belong to who? আচ্ছা না, আমার মনে হয় পুরোটা নিলে ভালো হতো। ভুল করছি।
আচ্ছা স্যার 120 হলে 30 ডিগ্রি রাইট সাইড হবে না 90 থেকে?
I appreciate your question, but I want you to think about the question that you just made. Think. If you still can get to an answer, I'll help you. Archo, did you get your answer?
Yes sir.
After thinking, you could get your answer, right?
Yes sir.
Beautiful. That's what I meant. So let's say this green one is the graph belonging to Y. So let me label this with Y. This is my Y graph. And then for the Z, cylinder Z, the oscillations of the piston, those are synchronized by an angle of 240 degree. So these are also leading those by 240 degrees. So we have to shift this peak by 240 degree to the left. Shifting 240 degree is same as shifting forward by 120 degree because this is a 360 degree cycle. ঠিক না?
জি স্যার।
So have a look. এই হচ্ছে এইটা ছিল আমার original position graph. This much is 90. I want to move this to the right by 1/3 of this part. So এটা হচ্ছে আমার আরেকটা 90. Let me label this for you. বলবা খেয়াল করো. I'm doing all this labeling to make sense with you. This is 90 degree. This is another 90 degree. So 120, so 30 degree to the right should be somewhat over here. If you wonder, sir, ডান দিকে সরাচ্ছেন কেন? Because I am telling you once again, the cylinder Z is leading by 240 degree. Leading by 240 degree is the same as lagging by 120 degree. I'm going for the smaller angle because drawing the graph for the smaller angle is usually easier to perceive and manipulate. Do I make sense?
Sorry, এটা বুঝিনি মানে like leading or lagging different না so leading goes by 240 why are you going to the right?
If you move a graph 120 degree to the left, it is the same thing as moving the graph 240 degree to the right, or vice versa, because moving the graph by 360 degree gives you the same position. এই লজিকটা বুঝো না, বুঝছো?
না স্যার বুঝিনি।
হ্যাঁ স্যার বুঝছি।
ওকে, মনে করো আচ্ছা আমি 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 একে দেখাচ্ছি। লেটস সে এটা হচ্ছে আমাদের গ্রাফ, এটা হচ্ছে সার্টেন গিভেন গ্রাফ। মনে করো এখানে আমাদের একটা গ্রাফ আছে। আই ওয়ান্ট টু মুভ দিস গ্রাফ 120 degree to the right. So I'm going to move this blue peak by 120 degree to the right. Let's say this much is 90 degree movement, and then 1/3 of that box. So let's say this much is 120 degree movement. Do you agree?
Yes, sir.
Okay.
Yes.
That's one shape that I get. Alternately, let's say this was the original position. Now I want to move this to the left by 240 degree. Now have a look. 240 degree moving to the left might be different for this peak because I don't have much graph left over here. So observe for this one. So observe for this one. If I move this one by 240 degree, from this position to this position is 90. From this position to this position is 180. Do you see that? এই যে এইখান থেকে এই পিক থেকে খেয়াল করো, I might as well label this red. Yes, I should label this red so that it's easier for you to understand, because there are too many blue curves. Oh, beautiful, amazing. Should I erase off these dotted lines? Is that going to be easier for you?
No, it helps. It helps.
Does it help?
Yeah, it does.
Sir, would you rather use Desmos, or are you comfortable using them?
Desmos কি easier হইতো?
I think so, sir.
স্যার এইভাবে করি না।
বলি Desmos করে যেটা প্রবলেম হইতো, I would have to manipulate the graph by changing variables in the equation, explaining why that variable changed.
Sir.
বুঝছো?
There's something you can do there's things called sliders, and put a variable and you can make it a slider, so you can vary it freely without changing the numbers.
In Desmos?
Yes, I can show you right now.
Damn it, I did not know that. Koloban, for those who think that we have almost done here and we can save time, I really know.
Make a quick curve like y is equal to 10 sin x.
Okay, hold up. Let me just draw y goes to minus cos x. This is our substitute first curve. Okay. So
okay, you can please alter the x-axis so it becomes like decrease, and it's between like.
Help me. This is supposed to be 90.
Step you can 90 degrees at the bottom, sir. Alter it to be degrees.
And yes, sir.
x-axis এর রেঞ্জটা আপনি অল্টার করেন 0 থেকে 360 হতে পারে।
Also 0 থেকে 360 এরকম করেন স্যার।
ঠিক আছে?
And sir, if you want to you can copy minus cos x and make another graph, not in reverse constants. Sir,
হ্যাঁ শুনতেছি আমি।
make another graph like y is equal to minus cos x.
So copy this.
Yes, copy this.
Okay.
And in the place of x, put x in brackets. Now write x plus a. Just add a plus sign. Yeah, add slider, sir.
Wow!
Sir,
how do I change the range of this thing?
Click on it. Not that, sir. Back. Click on this. Just minus 360 to 360.
Beautiful. You kids are amazing. I love you. Boom, 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 boom. I want you in my room. Yay. All right. So how can I stop this? Can I close this? No. I can manually move this, right? Okay.
Yeah, you can manually move this, and you can press the play button, so it just bounces back and forth between the ranges.
Perfect. Thank you. I love you. So this is really time consuming, and this is revelatory to me, to be honest. I did not know this use was there. I'm such a noob person, and I also don't use Desmos much, so it's not. So do you guys understand what is being done here? Hold on. The red graph is our original graph, and now the x should be 120 degree on the left. So I can move this 120 degree to the left. So minus 120. Yellow. Exactly this one. This is supposed to be my x. Sorry, y. বুঝতেছো?
Yes, sir. বুঝতেছি।
Yes, sir. Yes, sir.
x হওয়ার কথা না?
না, রেডটা হচ্ছে x. The original curve minus cos x.
Sir, expand the window, please.
Sure. আর এখানে আমি 120 degree to the left সরাইছি. So by moving this graph 120 degree on the left, we have got y. And then also we can also get a new graph. This is purple, and now I want to change the value of x. So I'm gonna give no.
So you can use another variable like b.
Yes.
Change the boundaries, sir. Change, not the animation, sir. The boundaries, just click on the, yes.
Should I give the steps at step দরকার নাই. Okay. So what is happening for B, the purple graph? So I want to move this to the right by 240 degree. So I'm moving this by 240 degree to the right. So I might as well zoom out a little bit. So moving it by 240 degree to the right. There you go.
Sir, but a leading graph ছিল না, sir. আপনি তো lagging করে দিলেন। Perfect দিলেন।
So have a look. Yeah. আচ্ছা, sorry, 240 degree to the left হবে?
Yeah, but ওখানে leading বলছিল না।
হ্যাঁ, ভুল লাগছিলাম। এখন ঠিক আছে। This was initially over here, so this was the initial case. Now I want to move this purple graph 240 degree to the left. So I'm moving this 240 degree to the left. So increasing, 240 degree, 240 is here. So now I have both of the graphs. This was my x, this is my y, this is my z. এখন ঠিক আছে কিনা দেখো সবার।
Sir, as you said, আপনার একদম পুরো like first যে পিকটা ওখানে 240 ডিগ্রি আসবে না, তখন কি করব স্যার?
কোনটা?
আপনার একদম পুরো ফার্স্ট পিকটা যে like আপনার minus cos x গ্রাফ। হ্যাঁ স্যার, আপনি বলছিলেন যে 240 ডিগ্রি স্যার আপনার like লেফট সাইডে যাবে না, তো তখন কি করব আপনি বলছিলেন, দেখাচ্ছেন।
এই ব্লু গ্রাফের পজিশনটা দেখো, ব্লু গ্রাফের পজিশনটা মাথায় রাখো, ঠিক আছে? Other than moving this 240 degree to the left, I could get the exact same shape if I moved it to 120 degree to the right. Same thing. That's what I meant.
মানে আপনি ব্লু কার্ভ থেকে 120 ডিগ্রি to the right করছেন।
হ্যাঁ, because 240 degree moving to the left is the same as 120 degree moving to the right, because the 360 degree is a full cycle. So I could have got that purple curve in this appropriate position by simply moving it to the right by 120 degree as well. That's what I was attempting to do, because moving 240 degree requires a bit more calculation, and moving 120 degree requires a bit less calculation. That's what I was trying to go for.
Sir, আমি কি red curve থেকে 120 degree to the right করব?
হ্যাঁ, red curve টাকে 120 degree to the right move করার মানে হচ্ছে 240 degree move to the left. They both mean the same motion or same position.
But why? Like why? That's not
because in a circle, if you start from here, consider all sin tan cos. If you move from here to here by 120 degree, you reach up here. If you move from here to here by 240 degree, you reach up in the same position. ঠিক কিনা?
Oh, sir, yeah. Got it.
Reference
Thank you.
angle.
বুঝা গেছে?
জি স্যার, থ্যাংক ইউ।
Beautiful. That's the logic.
Sir.
That TCG is a circular thing. So it adds up and subtract on both sides. বলো।
স্যার ওইখানে যে আপনি 120 ডিগ্রি রাইটে শিফট করেছেন গ্রাফটা, ওটা কি মানে ওটা তো জেড এর জন্য তাই না?
Yes, z এর জন্য, yes.
জেডটা কি উইথ রেসপেক্ট টু এক্স কে বলছে যে জেডটা এক্স এর সাথে ইয়ে করে এত নাকি ওয়াই এর সাথে মানে কম্পেয়ার করে বলছে? কোশ্চেনটা কি ছিল বলেছি?
কোশ্চেনটা পড়ো।
আচ্ছা বুঝছি।
ঠিক আছে? So now let's get to the question. The question says that complete the diagram of cylinder Y for this instant by drawing a line showing the top surface of the piston. Now, as you can see, because this image was drawn for t equals to 0 for the initial position when the X cylinder was located at the most lowest position, which is over here. You can see that both Y and Z should be located over here, right? Both Y and Z should be located
the halfway point,
halfway above the equilibrium point. Halfway above the equilibrium point. So this is your equilibrium halfway above, which means in the drawing, if I go for the drawing, let's say the halfway point is about here, assuming. So this should be somewhere over here, and this one should be somewhere over here. Both of these lines should be exactly at the same level. See if it makes sense. Because you can see that both of the graphs are at the same position, but there is a difference in the velocity. Have a look. All of these graphs are displacement versus time, right? So if you consider the gradient, you get the velocity direction. Have a look. The blue graph has a positive gradient over here. Do you see that? The blue graph has a positive gradient, and the purple graph has a negative gradient, which means Y is going upwards and Z is going downwards. So bam.
এই অ্যারোটা কি দেখাইতে হবে?
এই অ্যারোটা দেখাইতে হবে? হ্যাঁ, এটা দেখাবো স্যার। An arrow to show the direction.
ডিরেকশনটা কিভাবে পাইলেন? মানে একটু নেটে কানেকশন সমস্যা ছিল।
ডিরেকশনটা পাইছি হচ্ছে by observing the gradient of these two lines. The blue curve has a positive gradient over here. Positive gradient means upward velocity. And the purple graph has a negative gradient over here. Visualize the tangent and it will be easier for you.
So these curves represent the positions of these pistons.
Yes, all of these three graphs are displacement versus time graphs for the individual pistons.
আচ্ছা স্যার, কোন পয়েন্টটাতে আমরা গ্রেডিয়েন্টটা কনসিডার করব? মানে
at t equals to 0, the instance where X is currently at. This at t equals to 0. বলো
স্যার মানে t is equal to মানে যখন 0 ডিগ্রি হয় তখন তো 0.5 আসে না এখানে?
Yes.
এখন স্যার তাহলে তো হাফওয়ে তো মাঝখানে হওয়ার কথা না লাইনটা?
হ্যাঁ, মাঝখানে আমি তো ইকুইলিব্রিয়াম এবং পিকের মাঝামাঝি আছে. Let's say this was my assumed equilibrium position. I tried to draw this line.
Right. Thank you.
ঠিক আছে?
স্যার আমরা এখানে কি স্যার আপ ডিরেক্টিভটা পজিটিভ আর ডাউন ডিরেক্টিভ নেগেটিভ নিচ্ছি, রাইট?
Yes, because that's how the question was made. If you wonder how do I know that the question was made this way, have a look in this paper. It shows that when it was at the lowest position, the displacement was considered to be negative, which means they are considering downward as negative direction.
Oh, okay. Thank you, sir.
Sure. So have a look at the mark scheme. What does the mark scheme say? It might as well match right now. কত নম্বর question ছিল? Which was this one? 22. 22 mark scheme says line drawn at 2 cm above AV, line drawn at 2 cm above AV, arrow pointing upwards, arrow pointing downwards. Oh my god, the answer matched. So I have been doing this math wrong my whole life. The mark scheme is correct. Yay!
This is a milestone, sir.
Yeah, this is a milestone for me as well. But I might as well forget this. But I'll have the video to remind me of this. So which is amazing.
Sir,
বলা
2 সেন্টিমিটার আপ ডাউনের ব্যাপারটা কি ছিল আর একটু বলবেন?
এই পুরোটুক কত? এই পুরোটুক হচ্ছে 8 সেন্টিমিটার।
8.
Right. So halfway of this one means how much from here?
2 সেন্টিমিটার।
এইটুক হচ্ছে 4.
হ্যাঁ।
এইটুক হচ্ছে 2. So 2 centimeter below CD. upwards
ওইটা কেমনে বুঝলাম যে
2 সেন্টিমিটার হবে
পজিশনটা কি করে বের করলাম? ডিরেকশন তো গ্রেডিয়েন্ট দিয়ে বের করলাম।
পজিশনটা বের করলাম হচ্ছে যে এখানে তাকায় দেখে দেখো যে এটা হচ্ছে 1, ফুল অ্যামপ্লিটিউড হচ্ছে 1, হাফ 0.5 এ কাট, তো ফুল অ্যামপ্লিটিউডের চেয়ে অর্ধেক প্লেসে থাকবে the exact position at this time instant.
আচ্ছা স্যার, বুঝছি।
বুঝা গেছে?
স্যার এক্সামে
স্যার
কোশ্চেন পেলে
এটা আমরা স্যার এই ম্যাথটা আমরা 2 পাই বাই ল্যামডা ইনটু ডেল এক্স দিয়ে কেন করতে পারছি না, মানে ফর্মুলাটা দিয়ে, মানে ফেজ ডিফারেন্স ফর্মুলাটা দিয়ে?
We actually might be able to do that. I mean, this is a procedure that I showed you that actually works in my head for the idea of leading and lagging. But if you still want to go forward for leading and lagging, there is one more way that I can go for the figure that I just drew over here to make sense to one of our students. সেটা হচ্ছে এরকম বুঝাই। If I now use this mechanism to give you an idea, have a look. এই পার্টটা খেয়াল করো, বুঝার চেষ্টা করো কি বলতেছি। I might as well use 100% because I don't need that much zoom. Where is the circle? Circle is missing here. Where is the circle? What? Oh, এখানে আরো শেপ আছে, এখানে হার্ট আঁকা যায়। Oh no.
Stop.
And I can make a heart hit by lightning strike. Okay.
That's very symbolic, sir.
এটা কি ফ্ল্যাশের নতুন লোগো নাকি?
না না, ফ্ল্যাশে কি কোনো হার্ট ব্রেক হইছে? I don't know. I haven't seen Flash. I haven't seen Flash. আচ্ছা, আমি তোমাদের এই কনসেপ্টটা থেকে একটু বুঝা। আচ্ছা, আগে সাইকেলটা না আঁকি, আগে আমি একটা যোগ চিহ্ন আঁকা লাগবে। So let's say I am going to draw the axis system first. Black. And then being কি বলে creative here. লাভটা কি হলো? আচ্ছা, ব্যাপার না। So let's consider this is our circle. Okay. So I'm going to use this circle to transcend the idea into your head. I'm going to try. I have never tried this approach, so I might get stuck at places. So correct me if I'm wrong. As per the question, the X was located initially where? Let's say X is labeled by ash color. X was initially located here, right? Think, kids. X was located where? At t equals to 0, this was the position for X. Do you agree?
At the bottom, yes, sir.
Y was leading by 120 degree. Leading by 120 degree means 120 degree on the left. So Y was over here, 120 degree on the left. So Y was supposed to be this in a circular vision. This is supposed to be the Y position in the circular vision. So that this much is what? This much angle is 120 degree. And Z is supposed to be 240 degree lagging. Leading. 240 degree leading মানে হচ্ছে এই যে full 120 degree, এই যে full হচ্ছে 180 degree plus another 60 degree. So let's say over here. So this whole angle, so if I draw this line, this entire angle is supposed to be how much? 240. Do you understand? I'm going backwards because I'm trying to show the graph moving to the left. So the angle is supposed to be subtracted. Hence, clockwise angle, because clockwise angles are negative angles. See if it makes sense.
স্যার এক্সটা কেন ওখানে আছে, বাকিটা বুঝেছি।
Have a look at the position at t equals to 0.
আচ্ছা স্যার।
Bottom position, right?
Yes স্যার।
এখন আইডিয়াটা হচ্ছে আমি সার্কুলার মোশন দেখাচ্ছি তোমাদের অ্যাঙ্গেলের আইডিয়াটা বোঝানোর জন্য, বাট টু বি অনেস্ট এগুলো তো আর একটাও এরকম সার্কুলার মোশনে ঘুরতেছে না। টু বি অনেস্ট অ্যাকচুয়াল পজিশনটা হবে কিরকম, তুমি যদি সবগুলো পজিশন যদি শ্যাডো দিয়ে রিপ্লেস করো, মানে এক্স হচ্ছে এই জায়গাতে, ওয়াই হচ্ছে এই জায়গাতে, জেড হচ্ছে এই জায়গাতে, তুমি তো অ্যাকচুয়ালি লিনিয়ার মোশন পাবা। বাট টু গেট ইউ দ্য আইডিয়া অফ দ্য সার্কুলার মোশন, I'm covering this circular figure. So this is a clockwise circular angle of 120 degree, which brings your y over here. But if you now consider the motion, this is supposed to be moving upwards. and this is supposed to be moving downwards. Have a look. Do you see? So Z was moving downwards and Y was moving upwards. Is that the figure that we get? Yes. বুঝা যাচ্ছে কি বলছি?
Yes, sir.
So if you don't want to bother with this equation, this one might also help, provided that you can make sense between the circular converted to linear properly. This might as well be helpful.
Mark scheme ভুল আছে
Because I could never solve this question properly in this manner in an classroom environment, which did make sense to me ever. This is the first time, for which I'm extremely happy.
Oh, okay.
However, come to think of it, since you did understand what was drawn over here, I can very well do this thing right over here very easily right now, because since I did draw this figure, so I might as well prefer to complete this. So if I take this over here and do transparent selection. So have a look. Moving this left would essentially bring my Z graph over here. So blue is my X, green is my Y, and red is my Z. You can see over here at t equals to 0, here is the crossing point. So 2 centimeter above equilibrium or 2 centimeter below the highest point. And Y is moving upwards because the gradient is positive, and Z is moving downwards because gradient is negative. So you might as well get from this graph as well. But once again, once I draw these 3 graphs in a single space with 3 different color, the graph becomes difficult to perceive for many of the students. Many of the students are not even comfortable looking at a graph like this. In Desmos, it was easier to perceive because it gives us a much cleaner version. So it's easy to perceive in this environment.
So 2 centimeter ব্যাপারটা আরেকবার একটু বুঝাতে পারবেন?
This was half of the amplitude.
Yeah.
The entire amplitude was 4 centimeter. So this much was supposed to be 2 centimeter. This is 2 centimeter because this entire thing was 4 centimeter by according to the question. বুঝছো?
Yes, sir.
I feel happy. Abias, thank you very much for the idea of slider.
You're welcome, sir.
It was amazing.
When I discovered
It's
it, I
past
was
4 minutes, so I'm not gonna hold you back anymore. This was a long problem to solve. But before I move on, are we clear about these position marks?
Yes, sir.
Yes, sir.
Yes, sir.
Number 3 টা এখন খুব easily করতে পারবা? For the position in cylinder Y, calculate speed at this instant. Formula কি? Formula বলো।
Omega a squared
x squared minus x squared.
Centimeter per second, so you don't bother to convert this into meter, just place the values. But since this is going to be upwards that you just label over here appropriately, so you should give a positive value over here. Don't write the minus value. For cylinder Y, the speed, আচ্ছা কিন্তু স্পিড বলছে না, আচ্ছা সরি, ডিসরিগার্ড দ্যাট। স্পিড বলছে শুধু নাম্বারই হবে, প্লাস মাইনাস দিয়ে বদার করার দরকার নাই। যদি এখানে ভেলোসিটি বলতো, let's say if this one said velocity, you might as well write this much, comma, upwards. Write that in words. That's always safe.
তাহলে তার মানে কি ডিরেকশন যদি বলতে হয় তাহলে আমার আপওয়ার্ডস ডাউনওয়ার্ডস বলতে হবে। আমি
velocity বললে তোমার if the question demands velocity out of you, you need to mention magnitude and direction both, because that's what makes velocity.
তাহলে না, আমি ওটা বলতেছি না, বলতেছি যে ম্যাগনিটিউড তো দিলাম, সাথে আমি যদি মাইনাস বা প্লাস দিয়ে ডিরেকশনটা বোঝাতে চাই তাহলে কি আমার মার্কস দিবে না?
They might, they should, but I feel safe if you write it in words.
Okay. Gotcha.
Are we clear about this whole thing, everyone?
Yes, sir.
Yes, sir.
We'll pick it up, this worksheet, from this point next class. Thank you very much. The lecture will be uploaded in a couple of minutes, not in half an hour, let's say. So yeah. Thank you, kids. Bye.
Thank you, sir. All of us.
Dom শেষ হয়ে গেছে।